This is the 6.04 mole mass relationships lesson. An essential skill of any chemist is to be able to interconvert between moles and mass. In other words, change something from moles into how much mass it has. When conducting experiments in the laboratory, chemists must measure the amounts of reactants and products. The amounts are most often expressed in terms of mass, or in other words, grams. However, when substances are being compared, mass is not the best parameter. Instead, chemists use moles. In fact, an essential skill of any chemist is to be able to interconvert, or change, between moles and mass. You will learn how to do that in this lesson. Goals for the lesson: define molar mass, define the molar mass of a compound given its formula and atomic masses of its atoms, convert the mass of a molecular substance to moles. So, mole-mass relationship connects moles and molar masses, and it's found using formulas and/or atomic masses. On slide 2, you can get the student guide and the percent composition, empirical, and chemical formula. I strongly suggest that you get both of those. From there, I pulled the keywords and pronunciation. Formula mass is the atomic mass of 1 mole of an ionic compound expressed in grams. Molar mass is the gram amount of any element or compound that is equal to 1 mole of that element or compound. Mole, again, is 6.022 times 10 to the 23rd of anything. And then from the other sheet, I just copy-pasted it all into my notes. Percent composition, empirical, and chemical formula. When conducting experiments in the laboratory, chemists must measure the amount of reactants and products. The amounts are most often expressed in terms of mass, in grams. 1 mole, or N sub A, of any substance contains 6.022 times 10 to the 23rd particles. The mass of a mole varies with the substance. A mole of lead atoms has less mass than a mole of automobiles. So think about it. If I had a dozen eggs, that would weigh less than a dozen cars. Even though I would have 12 eggs, 12 cars, the amount that they weigh is different because they're different things. Same thing for the elements. Different elements weigh different amounts, as you can see on the periodic table. When we use the periodic table and chemical formulas to calculate the molar mass, or grams per mole, the mass of 1 mole of an element or compound. Element, the average atomic mass in atomic units, is listed on the periodic table. So I put a little screenshot of oxygen from the periodic table on my notes, and remember the top number, the whole number, tells how many protons. The number that is a decimal tells us the total of the protons and neutrons with all the isotopes. In other words, it's the mass number. So 1 mole of oxygen is 15.9994 grams, although usually we round, and we would say, or 16 grams. So 1 mole of oxygen is 16 grams. That's how much it weighs. Now, let's look at a compound. It's the sum of atomic masses of each atom in the chemical formula. So I have oxygen and hydrogen. Water is H2O. So 1 mole of water, or in other words, H2O, is made up of 2 hydrogens and 1 oxygen. Each mole of hydrogen is 1.00794 grams. And remember, there's 2 of them because it's H2O. And oxygen is 15.9994 grams. So again, let's round. 1 times 2. So 1 gram for every 2 hydrogen, okay, plus 16, because each oxygen weighs 16 and there's 1 of them, gives us 18 grams per mole. The molar mass of a substance is the atomic mass of that substance expressed in grams. Use these equations to convert between moles and mass. So molar mass in grams equals the number of moles times gram per mole. Number of moles equals molar mass, grams, divided by the quantity, grams, divided by mole. Honestly, don't bother memorizing this. If you asked me right now to spit that out, I couldn't. Why? Because I know how to figure it out. I don't need to memorize it. Knowing how to figure it out is going to help you more than trying to memorize. And I'll go through how to do that later. The percent composition is the amount of one specific element or ion in a compound, given as a percent of the molar mass. Percent composition is determined by the following formula. Percent composition equals molar mass of an element divided by the total molar mass of the compound times 100. And again, we'll be going through some examples of those. Chemists carry out reactions in the laboratory. Chemists conducting an experiment in a laboratory must measure the amounts of reactants used and products made. The amounts are usually expressed in mass, but may also be expressed in volume for gases. However, a chemical equation really only shows the number of atoms or molecules that react and the number of atoms or molecules produced. A convenient way for chemists to express the numbers of atoms or molecules is by using the mole. Therefore, an important skill for any chemist is to be able to convert from mass to moles and from moles to mass. This conversion is called the mole-mass relationship. Before you learn about the mole-mass relationship, review the concept of the mole. And under the picture, chemists must measure substances and know the number of moles they contain. The mole-mass relationship allows chemists to convert between these two quantities. A mole is a unit for measuring numbers of atoms or molecules. Atoms are so tiny that billions of them are needed to create even a small object. Keep track of such a large quantity requires a special unit. Chemists came up with such a unit called a mole. 1 mole of any element, molecule, or formula unit contains exactly the same number of particles. And what is that number, everybody? 6.022 times 10 to the 23rd. The mole is defined as the amount of a substance that contains as many particles as there are atoms in exactly 12 grams of carbon-12. Balanced chemical equations relate the number of molecules that react and produce product, so moles are important. All right, and then again, it goes over a chart. Go ahead and hit pause and read through this again if you'd like to, talking about how if we want to know how many molecules are in 5 moles, we just multiply 6.022 times 10 to the 23rd times 5. And I'm going to take this last sentence and add it to our notes because that is very important to remember the why. So it needs to be balanced and it relates to molecules that react and produce products, so moles are important. Moles and mass are closely related. A mole is a lot of atoms, but how many grams are there in 1 mole of any substance? The mass of 1 mole of any substance is called its molar mass. Okay, so the mass of a mole. The mass of the mole is the molar mass. The molar mass, or the mass of 1 mole of something, depends on the substance. So remember how I said a dozen eggs weighs less than a dozen cars? Same idea. A mole of eggs would weigh less than a mole of cars. According to the definition of a mole, gathering 1 mole of carbon-12 atoms would result in 12 grams of carbon. In other words, 12 grams of carbon-12 is 1 mole of carbon-12. Remember that carbon-12 has an AMU, atomic mass unit, of exactly 12. The abbreviation AMU stands for atomic mass unit. Use the average atomic mass of a sample of an element to determine the mass of 1 mole of the sample. Look at the periodic table. The average atomic mass of aluminum is 26.98 AMU. That means that 1 mole of aluminum has a molar mass of 26.98 grams, and the average atomic mass of arsenic is 74.92 AMU, so 1 mole of arsenic has a molar mass of 74.92. Okay, so we have put that in our notes right here already. The average atomic mass is listed on the periodic table. So 1 mole of oxygen is 15.9994 grams or 16 grams. So the molar mass equals the mass of 1 mole. Use the mass number on the periodic table and label it as grams. Okay, that's it. Which mass do I use? Now remember, this talks about that it contains the average number. Usually you round to about hundredths, and that will be good enough. So usually you round to about hundredths. All right, molar mass is the mass of a mole of a substance. The mass of 1 mole of a substance is called the molar mass. What is molar mass? the mass of 1 mole of a substance is equal to the atomic, molecular, or formula mass of the substance in grams. And as a reminder, formula mass is the atomic mass of 1 mole of the ionic compound expressed in grams. Molar mass is expressed in grams per mole, or G over mole. The unit mole is the abbreviation for mole. Remember these abbreviations because you will be working with them in this lesson. All right, so I'm going to pause for a second and put a few things into our notes. So even though some things are on here again, higher up, I'm going to go ahead and put them again below. Because sometimes when you're reading these words over and over, it's easy to get a little bit confused. And so having them down again will be helpful. So please make sure that you are taking additional notes or the same notes, whatever you find will be helpful. All right, and to find the molar mass of a substance, you need the chemical formula of the substance and the periodic table. That's it. All right, and before we do that, we'll quickly go through these. So average atomic mass. Okay, I said quickly, but apparently it doesn't want to load. A big key for this lesson is to make sure that you go over the vocab words and really just kind of take your time and do it one step at a time. Okay, I give up. It's not loading, so we'll keep going. Calculate molar mass. The molar mass of an element is the average atomic mass listed in the periodic table expressed in grams. The molar mass of a compound is calculated by adding the molar mass of each atom in the chemical formula. For each element in the formula, do the following. Step 1. Find the average atomic mass of each atom in the compound. Step 2. Multiply each atomic mass by the subscript in the formula to get the product. Step 3. Add all the results. All right, so how do you calculate the molar mass? So what's my molar mass of oxygen? 15.999. And that's also the atomic mass or the mass number. Now if I'm doing water, H2O, I need to find both of them. So hydrogen is 1.0079. Oxygen is 15.99. And then I look, how many hydrogens do I have? Well, I have 2 of them, so I'm going to have to multiply this by 2. So 2 times 1.0079 grams per mole is going to give me 2.016 grams per mole. There's only 1 oxygen, so I keep it as 15.99 grams per mole. And I add my results for my final answer of 18.01 gram per mole. And as you see, they rounded to hundredths. For my class, I suggest just always rounding to hundredths. It just makes things easier. Look at more examples to calculate molar mass. Follow along on the periodic table. Average atomic mass can be rounded. Keep in mind that atomic masses are expressed in atomic mass units, AMU. Remember too that even though the molar masses are different, the number of particles is the same. So even though, if we back up here, a mole of hydrogen weighs 1 gram, a mole of oxygen weighs 16 grams, both 1 mole of hydrogen and 1 mole of oxygen contain how many atoms? 6.022 times 10 to the 23rd. All right, example 1. Calculate the molar mass of sodium chloride. So you look up sodium, how much is it? It is 23. And then you look up chlorine. And my computer just died, so hopefully it's going to save my recording. I'm not even sure if you can hear me, but that is why everything just went dark.